Experiment 6 at Another Lab. So what we are going to do in this experiment is multiple process run. So first I have a data set called DJIA table ECA.csv, and we want to read it to a variable called myData. And we need two packages called neural net and ggplot. So we install the packages and we import the packages. That's what we do here. After that, we define a function called normalize. So what it basically does is it's going to standardize the values into a range of between zeros and 1. The technique is it is going to take a random value of all the attributes, and it's going to take the difference between that value and the minimum value of all the available values in the attribute, and divided by the greatest difference between any two values. So the greatest difference between any two values is simply the difference between the maximum value and the minimum value. So it's going to bring any value in the dataset to something between 0 and 1. And after that, we're gonna let's run that part. After that, we're gonna apply some function on the my data. So here we're gonna apply the normalize function, and we're gonna normalize the data set called my data, and you're gonna convert it into the data frame and store it in my in data set. So do that. After that, we're gonna take the maximum. We're gonna find the list of maximum values and minimum values in every column. So to do it, we use apply function. We're gonna apply the maximum function and minimum function in the data frame, and we're going to do it column wise. That's why we have a parameter as value as 2, and yeah, that is it. Then we're gonna sample the data. Okay, this is pretty much standardizing all over again. Yeah. This is like the as you can see, all the values has been converted to something between 0 and 1. Then we're going to divide the data set into training data and testing data. So we're going to use a sample function here, and what we're going to do is out of all the instances we have, that is from 1 to n row of data, that is the number of rows, that is all the rows, and we're going to take 70% of it, that's 0.07 into the number of rows, and the sample values is going to be on int, and we're going to be into you're going to use this is like a list of all the values which is sampled, and in the data frame you're going to take all the sample values and make another data set called train data, and you're going to take and this is another thing, you want to take the complement of all the selected or the sample value sample instances. So all the instances which are not in training data are going to be in testing. So we have two data sets for training and testing. One for training or for testing. Then we're going to take all the column names, and you can see okay, this part is basically construction of formula. It's not necessary to do it in this many lines, but anyway. So a formula is going to have the label and a tilde symbol and the attributes which you want to use to generate the model or in the model. So that's what been done here. Then here we call the function called neural net. And neural net, we have a number of parameters, and hidden says the number of layers. So we have 2 layers and 4 nodes in one and 2 nodes in the other one. Then we're going to use the training data, and we're going to use the activation function called logistic. So a neural net function has many activation functions. So if you look inside the documentation, you can find even more, and we have to find which is the appropriate one for the data set we are using, and we want to use that. So now let's plot and see the names of the results. So this is the plot we found, and these are the components in the plot. So we can find that using the names function. And the next part is testing what we created, the model just we created. And for testing, we are going to use a compute function, and the compute function is going to test this model against this data set, test data set. And the predictions are another variable called predictions. And later we're going to see what are the components in predictions. And yeah, we'll see. So predictions has a component called neurons and new net result. So what we're going to do is we're gonna make a table consisting of the predicted values and actual values. So first we will standardize the values. For that we do this. So we standardize the value of the actual values and the predicted values using a formula, which is similar to the normalized technique. So After that, you have a table which consists both actual values and predicted values. You can see it here. See, this is table. This table has actual and the predicted values. So now what we're going to do is we're going to find the mean square error. Mean square error is nothing but the difference between the actual values, predicted values, and the total and square of the distance between actual values and the sum of the squares of the distance between the predicted values and the actual values divided by the number of rows in the test data. And that you can see the mean square error. Okay, now you can plot a graph between actual values and predicted values. And yeah, these are basically the parameters. It's nothing like you want actual values in the x-axis, predicted values in the y-axis. This is the shape or the size that's given by PCH, and the color we want to use is blue and red. And this is the title, and this will plot the graph, and this AB line is going to be the line which is going to link uh, plots. So basically that. Okay, yeah, this is the plot, and this is the line. So you can see a line here, and that is all. Thank you.